Hey, it looks like it is just about that time. So we need to get a move on. And let's see what it is we are going to do with this lesson. Okay, we want to be able to find the length of a line segment. Quick reminders. A point has no dimension. We represent it with a dot. We use a capital letter to name it. A line has one dimension. It goes on forever both directions. Use arrowheads. And we can name it with a lowercase letter, or we can name it by two of the points on that line. Right? Lowercase cursive for lines, capital letters for points. We've talked briefly about segments before. Unlike lines, segments have endpoints. We've talked about rays. Rays are the ones that are tricky because you have to list the letters in the correct order depending on where the endpoint is. You must start with the endpoint. One thing we've not talked about, opposite rays. If two rays share the same endpoint, but they go in opposite directions, instead of making an angle, they are opposite rays and they actually make a straight line. Okay, now for distance. All right, if we get a line segment, notice the line segment could be part of a line. If I want the distance between A and B, I write it with just AB with no symbol over it. And we've got to figure out the absolute value. So that X with the subscript of 1, that's a fancy way of saying, hey, the number that goes with that point. That's the first point. The X with a subscript of 2, it's like, hey, that's just the number that goes with that point. All right, so let's do a couple of examples here. We want to find the length of each segment. First up, segment MN. Oh, it looks like distance would be 3. Right? 4 take away 1 is 3. How about the length of segment LN? That looks like a value of 6. Right? 4 subtract -2 would be 6. Number 3, distance from K to J. Distance of line segment KJ. Well, -3 subtract -5. That's a +2. JL. Well, it looks like I've got -2 subtract -5. That's going to be a +3. All right, segment addition postulates. If 3 points are collinear and otherwise you're on the same line or same line segment, you can say that one point is between the other two. So, for example, point B is between points A and C. And then another example, point E is not between points D and F, right? They don't lay on the same line. If they are collinear, notice that the distance from A to B plus the distance from B to C is equal to the distance AC, right? So if I find the length of each piece, I can add them together and they make the total length. Algebraically, that's how we're going to represent things. So if I want to find DF, here's what I'm going to write down my paper first. I'm going to put DF equals DE plus EF. All right, the length DF equals the length DE plus the length EF. Notice I'm using distance and length interchangeably here. The distance from D to E is also the length of the segment DE. And of course, I can substitute 23 for DE. I can substitute 35 for EF. And that, of course, adds up to be 58. So that's the length from D to F, or it's the length of line segment DF. Now, in this example, that 36 is showing us the length of FH, right? That's the distance from F to H. And then that 21, that's the length of FG. Now, again, algebraically, what am I going to do? I'm going to start by writing down FH equals FG plus GH. We know FH is 36. We know FG is 21. Now I can solve this equation. Now remember, GH is the length of a segment. It's not variable G times variable H, right? There's no multiplication there. Subtract 21 from each side. And we now know that the length of segment GH is 15. And it looks like it is time for a worksheet. Oh, some utensil grammar. Fork, 3, 2, 1, 0. Right? A fork has 4 sharp points. A 3 has 3 sharp points. A 2 has 2 sharp points. A 1 has 1 sharp edge. And a 0 does not have any sharp points or edges.